Let's play around with profiling data and cleansing it a little bit. And in order to clean some data, first we need some dirty data to play around with. And this is a good example of some data that could use some cleaning and profiling to understand its attributes. This is the online retail data set from the UCI machine learning repository, just to give credit to the source. Now I'm going to be using a CSV version copy of this data. And if you go to the URL that's about to pop up on the screen here, you can download that for yourself if you want to play along and follow along using Microsoft Excel and Power Query. So let's spark up a new workbook in Excel and launch the Power Query editor by going to the Data tab and then going to Get Data. And we'll load that from a file, which is a text CSV file, and download to wherever you downloaded the online retail.csv file. All right, so this is looking good. It automatically figured out the delimiter of the comma there. Not too hard to figure out. And fortunately, this data does have a header row, so we don't have to manually type in all these field names. So what do we have here? The invoice number, a stock code, an item description, quantity, the date of the invoice, the unit price, a customer ID, and the country that it was bought in. All right, seems pretty straightforward. So how do we interpret this data? Well, just by looking at it, it seems that we have multiple lines on each invoice. So we have many line items on invoice number 536365, for example. And on that invoice, which seems to be tied to one customer ID, they bought all this stuff. So they bought specifically they bought 6 white hanging heart tea light holders, 6 white metal lanterns, 8 cream cupid heart coat hangers. Already we can see there's something weird about this data, right? This doesn't seem like normal people buying stuff. So let's refer back to the description of this data set and see if it can give us any insight. So it says that this is transactions occurring between 2010 and 2011 for a UK-based and registered non-store online retail. What does non-store mean? The company mainly sells unique all-occasion gifts, and many customers of the company are wholesalers. Okay, well, that explains a lot of that behavior. So what looks at first glance to be a bunch of outliers is actually wholesalers buying things in large quantities to resell themselves. So it seems that this is basically a distributor of gift products. So that's some useful information to have. Also, it tells us a little bit more about the fields themselves, what the data types are, some interesting things about them, like if the invoice number starts with C, that indicates a cancellation order. And yeah, we have the stock code, a 5-digit interval number. Description is obviously a item name, quantity, all the stuff that you would expect. All right, so let's go back to Excel and continue on in importing this data and transforming it and, well, profiling it first of all. So yeah, this all looks reasonable. So let's go ahead and load this up. And this is a large data set. I think there's about 500,000 rows in it. There we go. Just making it real. Cool. All right. So let's try to get a handle on what we're up against here. So if we double click on this query here for online retail, we can get back into Power Query and play around with this a little bit more. All right. So we have these distributions here, these data distributions. So this is one way to start profiling our data here. Now, these views are going to be based just on the first 1,000 rows to keep things nice and fast, but let's assume that those first 1,000 rows are representative of the data as a whole for now. So what's going on here? First of all, let's take a look at the invoice number distribution. And since these are wholesalers, I guess we shouldn't be too surprised that there's a lot of individual line items associated with any given invoice. So it looks like the biggest invoice is 536464 with 85 individual lines on it. So they ordered 85 distinct things and possibly in multiple quantities of each one. So yeah, I mean, not a whole lot to worry about there. That doesn't look too weird given the context. But looking here, you can see from the min and max that, yeah, these are not just numerical values. So as we're starting to understand this data and profile it, it's good to know that this is not actually a numeric value. Looking at that at first glance, you might say, oh, that's an integer. I'll just treat it as such. But no, actually there's letters in it. Like it said in the description, if there's a C in front of it, that indicates it was a cancellation. So we cannot assume that the invoice numbers are numeric values. They are, in fact, text values. So that's an important insight right there. Let's take a look at the description field here, try to understand it. So again, here we're looking at the distribution of these values for the descriptions, and obviously this is not second normal form, they're actually writing out these item descriptions on each individual line instead of referring to some item identifier with a lookup somewhere for the actual name. So not the best use of storage space here, but makes it easier for us to wrap our hand around it at least. So we can see that in the first 1,000 rows at least that we're looking at, the hand warmer Scotty dog design shows up an awful lot. So nothing too weird here. You can tell this is definitely a UK-based store. I love London tea towels. Man, it's just screams out England, doesn't it? Union flag, hot water bottle. Anyway, fun stuff. But what can we gather from these column statistics here? So something interesting here is that there is at least one empty string within this first 1,000 rows. So it seems we do have an issue with missing data in this data set. I'm sure that's not the only one, since we're just looking at the first 1,000 rows out of 500,000. So one thing that we've learned by profiling the description field is that there are empty values in there. There is missing data, and we need to decide how to deal with that. Let's also look at the quantity field in some depth. And that's interesting. So you can see here that this distribution goes out really far. So even just looking at the first 1,000 values, there are definitely some outliers going on here. There's somebody who ordered 600 of a given item here. So again, you need to sort of understand the context of your data here. I wouldn't actually probably choose to throw that out necessarily, because these are wholesalers that are buying from me. So yeah, maybe someone really did want 600 of some item because they thought they could sell that to somebody else. Also, you can see that there's a lot of negative values in here as well. So -12, -1, -6 pops up. In fact, the minimum we see here is -24. So presumably those are returns. So we need to understand that the quantity can indeed be negative, and we need to know what that means. It probably means items were returned, right? So we can't assume that the quantity is a positive number. When we're presenting our analysis of this data, we need to keep that in mind. And again, it's telling us here again that the maximum is 600, and we need to decide, is that really an outlier? Well, statistically speaking, it is an outlier most likely, but do we really want to remove that from the data set? Unless we get more information about the context surrounding that order of 600 units of something, it probably represents a real purchase. So we'll err on the side of caution there for now and leave that in. Let's also look at the unit price field. So something interesting here is that there are 0 values in it. So what is that supposed to mean, right? The minimum is 0, max 165. All right. Well, it might be worth digging into what actually costs 165 pounds from a gift shop, but that's something to explore further later on. But we are seeing items that have a 0 unit price associated with them. I'm not sure I believe that. So that might be an example of something we want to clean up later on. It probably is some administrative entry of some sort where they're just, well, I don't know what they're doing. We'll have to look at it later on, but keep that in the back of our heads. There are unit price zeros in here, and I think it would behoove us to understand where those are coming from. And let's take a peek at the customer ID as well. Nothing looks too fishy here. There is an empty one though, so that's interesting to see. So apparently empty customer IDs are a thing. I wonder how common those really are. So let's change this to the entire data set. So instead of just profiling based on the top 1,000, I'm going to change this to the entire data set here. And given that there's 500,000 rows, that might take a little bit of time. And it seems we actually have 135,000 empty customer IDs. So what is that? Do we want to import that data at all? If we're doing an analysis based on individual customer behavior, maybe those rows are just cluttering up our database and our analysis. Maybe we want to get rid of those. So again, by profiling this data ahead of time, we can sort of get a feel of what sort of cleansing this data might require ahead of time. So let's go ahead and do some of that cleansing. First of all, we noticed that the description had some empty fields in it. So we talked in the lectures about one way of dealing with missing values is to just replace it with something else. So, okay, fine, let's do that. Let's go to the description field. And now that we're actually looking at the entire data set here, we can see that empty descriptions are actually pretty common. There was 1,454 instances of an empty string there. So let's replace those empty strings with something like no description. Let's just right-click on the description column here and say replace values. And we'll say the value defined is nothing, and we'll replace that with no description. Okay. And I still have this set to profile based on the entire data set, which is going to slow me down. So let's go ahead and change that back to the top 1,000. That's better. So let's click on that description field again. And now we no longer have any empty strings at all. I remember there was at least one in that first 1,000 previously. So looks like that did the right thing. We retained the existing ones, and presumably any empty ones have been replaced with no description. We'll search for that later. You can see the actual query up here that resulted in. What else can we do? So we saw that empty customer IDs are also a thing. And depending on the kind of analysis we're doing, that might indicate a row that we don't want to deal with. So one way of dealing with missing data is to throw it away. There are other ways of dealing with it that we'll talk about later, but for now, let's just illustrate getting rid of all the empty rows where there is no customer ID. So let's just click on the customer ID column here, and from that little drop-down arrow, I can very quickly say remove empty. Bam. So let's click on that again, and we can now see that nothing is being reported as being empty in the customer ID field. Just to double check, let's go back to the entire data set again. And sure enough, we now have 0 empty customer IDs in the entire data set again. Put that back to the top 1,000 so this doesn't take forever anymore. One more thing we can illustrate is dealing with duplicate rows. I'm not sure if we actually have any in this data set, but we talked about that in the lectures, so let's just show how you might do that in Power Query. So how do I identify a duplicate in this data set? Well, it seems like there's some unique combination of the invoice number and the stock code and maybe the customer ID. So you would expect for a given invoice number to not see the stock code more than once for a given customer, right? So let's assume that looking at those 3 columns, we can define uniqueness of a given row. So let's select those 3. We have the customer ID selected already. I'll hold down the Control key and also select stock code and invoice number. And now I can go to Remove Rows, little drop down there, and say Remove Duplicates. And again, I don't think we actually had any duplicates to begin with, but if we did, that would be one way of handling it in Power Query at least. Now again, I'm going to say it again, the exam is not going to quiz you on the details of using specific tools. You will be expected to know the capabilities of different tools and maybe their history a little bit, but the actual operation is not important for the exam. So I'm hoping that by playing around with this hands-on, we've cemented some of the ideas about profiling your data and starting to clean it before we import it. So let's actually load this now that we've transformed it in Power Query. And there we have our resulting data set. Still loading up. So one thing we can see right away is that we're down to 396,000 rows. If you remember, we started with over 540,000. So we have successfully cleaned out all of those empty customer IDs from our data set. So again, we're assuming or imagining that we're doing an analysis that depends on customer information, and we just threw out the information that had no customer information. So cool, looks like that worked. And if we're curious, we could do a quick search for that no description field. No description. Interestingly, it did not come up. We definitely saw that that transform was applied in Power Query, so the fact that we're not actually seeing it, I think, is telling us that those rows that had no description also had no customer ID. So that kind of gives me a little bit more confidence that the data that we threw out actually was weird in some way and probably not helpful for our analysis. So there you have it, a little bit of simple manipulation of our data. We took a look at our raw data, which was very unclean. We profiled it to understand the ways in which it's unclean, and we took some steps to clean it up. So I hope that's helpful. Let's move on and talk about these concepts in more depth in the next section.